The laser engraver company Twotrees has kindly sent a laser engraver for me to review, so let's take a look. Inside of the parcel are actually 3 boxes. These are labelled A, B and C. It would seem apparent that they're labelled so because there's a particular order of assembly. Before we open up the boxes, Twotrees also very kindly sent me this. This is a 1064nm infrared laser module that's capable of engraving metal. This is actually only rated at 2 watts, but the story behind this is quite complicated, so make sure you keep watching till the end. We'll just have a quick look in the boxes. This is box A, and as you can see, I got quite excited with the Stanley knife when I was opening up the parcel. But right away, we've got a product manual. Very, very nice. There's some nice diagrams in there. We can see a drag chain on the top. That's really nice to see. It looks like some other bits and pieces in there as well. So here's box B. We'll take a look and see what's in there. Some usual foam. Oh, nice. So we've got some test materials by the look of it. Not too much in the way of test materials, but it looks like we've got a piece of plexiglass here, a stainless steel tag, because apparently we can engrave stainless steel with this thing. That might be PVC. If it is, we'll talk about that later on. Yep, very nice. It looks like we've got a gantry in here. We've got a stepper motor with anodized parts. Very, very nice. We've got a power lead. This looks like US, so I'll have to do something about that. A paintbrush. I'm not entirely sure what that's about for dusting stuff off. Wires, cables, collection of bolts, so some assembly required. Excellent. We'll have a quick look in box C, and it looks like we've got the main frame of the laser engraver here. It looks like they've actually printed on here graduations. These look like they're in millimeters. Very, very nice. It'll be kind of handy for lining things up. I wonder if there's a pointer or something on there. But yeah, looks very, very nice indeed. Obviously, I'm very keen to see how this engraver performs, so I'm going to go away just now and assemble it, and then we'll take our first look at it. I've finished assembling the Twotrees TS2 Laser engraver here. It has to be said, this thing is absolutely enormous. I had to actually cut out the back of my shelf here in order to get it to fit on the bench. Anyway, let's have a closer look. It took just over an hour to assemble the laser engraver. I thought the manual was really quite clear. Plenty of pictures in there to follow. For those of you who prefer to watch video installations, Twotrees actually have a bunch of videos available on their website. Most of the parts are actually pre-assembled, and the belts on these actually appear to be pre-tensioned as well, which is to say that when you start to assemble the main parts and you have to loop the belt around the drive pulley for the motor, for example, it's actually already really very tight indeed. So my suspicion is that these have been pre-tensioned in the factory, which is pretty nice as well. The only fiddly job out of the entire install actually was the installation of the drag chains. As I've said, you know, this is quite tight in terms of tolerances when you put things together, and the drag chain has been precisely fit to the laser itself. So when you come to install the y-axis, for example, it's relatively straightforward, but then when you've got to bend it and move it to get it to go along the x-axis, it's pretty tricky. What I would say about that is, like with any other hardware build, if you find that you're having to try and force something, you're probably doing it wrong and you should have a look at the manual. But other than that, like I say, everything's together, everything's very, very snug, everything's very, very tight. It's actually really quite a nice build indeed. This thing is built like an absolute tank, by the way. It's really quite heavy when you come to lift it, so you know it's fairly difficult to move. Very, very sturdy. I'm convinced that I could sit on this and probably not damage too much. And I'm not exactly super slim, right? You know, part of the reason why this thing is so very, very large, as well, as I've already remarked before, I had to cut the back of the shelf out here in order to get it to fit on the bench. It has a huge bed size that puts the carbon dioxide laser I have out in the shed to actual shame. So just have a look at the main features real quick. As I've remarked before, this frame is very, very sturdy indeed, but it also has graduations printed all the way around it. So I suppose that makes for, you know, pretty easy positioning of the, you know, pretty consistent and easy positioning of the laser on the workpiece. The graduations themselves are actually mentioned in the manual. It's part of the alignment procedure. Initially, when you're aligning the crossbeam here, you've got to make sure that both ends of the carriage are lined up on the frame themselves. So yeah, it's pretty useful for that, I suppose. It would be convenient if these graduations actually stopped at about 0 here, which is where, approximately the center of the laser spot would be, but it's fine. The drag chains that I mentioned earlier actually come with all the cables pre-installed, and they actually have an airline pre-installed as well. The airline goes all the way down here, so this is the air assist for the laser. You can get much cleaner cutting with an air assist. It's kind of nice to see this thing actually already built in and tucked away. It's like I say, it's already built into the drag chains. Very, very nice indeed. There's a front window down here which is laser safe. If you actually look through here when the laser is in operation, you cannot see the spot at all. So I suppose the idea is to catch any beams that might, if you were engraving a specular surface, to catch any beams that might come off in the general direction of the operator. As with all lasers, laser safety goggles are supplied and required for working with lasers. But yeah, a nice extra feature as well. I've noticed that the two sides are left open, and presumably this is so that you can work on much larger pieces of wood, for example. If you've got a large sheet of plywood, you just be able to run it through sideways. We'll turn our attention to the laser itself. This is a massive 20 watts of laser power at 450 nanometers in the blue. The spot that comes out of this is very, very small. It's sub-millimeter. In fact, I think in the manual it said it was something in the region of about 0.08 millimeters in diameter. So a very, very small spot. 20 whole optical watts into a spot that size. It should be able to make a morsel out of anything that we put under this thing. So very, very nice indeed. Interesting feature on this, I've seen on some other laser engravers that the guard around the thing can actually be removed. In this case, it's actually integral to the laser itself. You cannot remove the guard, and I would suggest that that's probably a good idea. From a safety perspective, there shouldn't really be a reason to be removing guards off of things. At the front of the guard is another filter. This is another laser safety filter. This is actually coated glass, which is really, really unusual. It's quite common to see like plexiglass guards for these things, but they've actually used glass for this. A very, very interesting choice indeed. Talking about laser safety features, there's a couple more that might not be too evident with this. Apparently, if you tip this thing up at about an angle of about 15 degrees or so, it will actually cut out. So whatever laser engraving job you happen to be doing, it will just shut the machine off. So presumably, if you were to, for whatever reason, have it fall off a bench, I mean, that's going to ruin your day anyway, without 20 watts of laser beam shining across the workshop. So yeah, pretty nice feature. We've got an emergency stop here, which is pretty handy. I've actually used this already when I was setting up a test piece for this. And there is a flame alarm as well. So if you happen to set something on fire, the alarm will go off and the machine will immediately stop. So some really very nice safety features indeed. It's really nice to see manufacturers actually paying attention to this stuff. I think in the end, what I would really like to see on a machine like this is a key switch, so that unauthorized users can't just come along and start messing with your stuff. That being said, nobody comes in here other than me, but still, I think for belt and braces and probably to be like CDRH compliant and so on, probably requires a key switch on this thing. But other than that, really, really very nice indeed. A really nice feature on this machine that I've not seen on any other laser engraver is the Z-axis control for focus. There's a little knob up at the top here that we can move the laser in and out from the workpiece, and potentially we could set it with blocks as we might do on any other laser engraver. But this also has attached to it a stepper motor, and this is connected up to the controller, and this means that we can control the Z-axis through software. This, to my mind, sort of moves this laser engraver from being a sort of hobbyist tool really into a serious tool that you could, use in a production environment for making stuff. So very, very nice indeed. Additionally, machine files are actually included by Twotrees for both laser Gerbil and Lightburn, that you can just import all of the settings from the machine into Lightburn, for example, and start engraving or cutting or whatever. This results in an almost zero setup in terms of software, which is very, very nice indeed. In Lightburn, and we'll have a look at that shortly, when you import the machine settings for this, it actually pulls in macros for the Z-axis. So you can actually move the laser, 20 millimeters at a go above your workpiece in order to get your workpiece under there and initially set everything up. And then you've got basically automatic focus. So if you want to engrave, you just hit the engrave button and it'll lower it to the correct height for engraving. If we're cutting, 3, 4, 5 millimeter plywood or whatever, there's a button for every one of those as well, because the focal point is essentially supposed to be in the middle of the workpiece when you're doing something like that. Really, really very nice indeed that this stuff is already set up for you. Absolutely fantastic. So we'll just have a quick look at this Z-axis control real quick because it's really quite nice. At the back of the laser head here is a probe, and it's that probe that's used to determine the optimal distance from the workpiece. If I head back on to Lightburn real quick and just press Engrave, we'll see the head lower, the probe will touch the workpiece, and then it'll calculate where it should be for the engrave operation. Absolutely fantastic. Really, really nice. Obviously the laser doesn't come with any kind of bed or base, otherwise how on earth would they fit it in the box? So I've got a piece of scrap anodized aluminium here to do my engraving on today. Since it is anodized, we should be able to just engrave this piece of scrap directly, so let's do that. This laser's done a fantastic job of engraving this anodized aluminium here. This would be ideal actually for marking front panels for electronics projects and stuff like that. Absolutely superb. So I'll have a go with aluminium business cards. These are actually anodized, but as we can see, they're not black. They're quite light in color, like a light blue or turquoise. We'll have a go and see how this performs. Now the job's finished, let's have a look. And that is very, very nice indeed. I'll try one of the test pieces from the kit here. This is a piece of stainless steel, and apparently 450 nanometer laser diodes will actually engrave stainless. So I'll just put it on my test bed here. I've actually scribed a rectangle so I can line this thing up, and we'll give it a go. And that's the job finished. Let's take a look. It's looking good already. Very, very nice indeed. I'll see if I can get the light to catch it. There we go. Excellent. So I'll just do one more materials test real quick before I move on to the infrared laser module, which is what I'm really interested in. I've got a piece of 3mm thick plywood here and a small job loaded into Lightburn. Let's see how we get on. So that's the job finished. Let's see how we got on. Very, very nice. Nice and fast. A decent engraving on there with some very, very fine engraving lines. Very, very nice indeed. Twotrees very kindly sent me their infrared 1064 nanometer laser module, and it's this that I'm really excited about. The average output power of this is only 2 watts, and that seems really quite insignificant when you stack it up against the 20-watt diode laser that we've just seen. But something really special is going on here. This actually is a pulse laser. It emits a train of pulses, somewhere in the region of about 1,000 to 2,000 pulses per second. And each one of those pulses is very, very short in duration, somewhere in the region of about a nanosecond or so. The available energy in each of those pulses, the peak energy that's available, is actually 75 kilowatts per pulse, which is enough to vaporize any metal, almost any metal. I would say it would probably struggle with tungsten, right? But everything else, aluminium, stainless, brass, gold, silver, you name it, there's enough power available to actually vaporize the material. This isn't actually capable of cutting anything, but it should be able to engrave all metals. There's a manual included that shows you how to install this laser into the Twotrees TS2, which is very, very handy. It needs some significant reconfiguration, but I'm sure it'll be just fine. And there is also an updated power supply for this. One thing to watch out for is that this power supply is 12 volts. So this particular laser requires 12 volts at like 9 amps to run it. And the original diode laser in the TS2 requires 24 volts. So for the love of God, don't mix up the power supplies or it's going to ruin your day. Make sure you're using the correct power supply for the correct head. I have the 1064 nanometer head mounted onto the Twotrees TS2. The installation was relatively straightforward. The manual's really quite clear as to where things go. You'll notice that there's a little red spot under here. There's a little guide beam to point you in the direction of where the infrared laser spot is actually going to be, because remember, it is invisible. I have a little job loaded up in Lightburn, and I've got a piece of scrap aluminium to test here. Before we do anything else, always make sure that you're wearing appropriate laser safety glasses. This thing is invisible, you will never see it, and if mistakes occur, you'll never know about it till it's too late. So our job stopped now, let's see how we did. Oh wow. Look at that. Just wait while the light catches it. Very, very nice indeed. So I have here some copper clad board, the kind of stuff that you might make printed circuit boards out of. It turns out that the laser just doesn't have enough penetrating power to be able to effectively cut the layers. It is possible to separate copper with this, but you end up with a kind of a low resistance bridge between it, which is probably oxide and burnt PCB, I would imagine. But we can sure as hell engrave on it, so let's fire this a job. So there's the completed engraving. Very, very nice. A wonderful black oxide layer it appears to be to me. This laser is excellent at marking things like ABS and anodized aluminium, and is absolutely fantastic for things like project boxes. This has done an absolutely fantastic job and can make all the difference between your project looking amateurish and professional. Very, very nice indeed. We'll see how this copes with a highly reflective surface and indeed a curved surface like this spanner. This laser's done a fantastic job even on a shiny and curved surface like this. Very, very nice. The Twotrees TS2 Laser Engraver is a fantastic machine that could easily compete with small carbon dioxide lasers. If you're intending on running a business with something like this, I would highly recommend getting the 20-watt head because it really is quite fast. As we've seen, it's capable of cutting plywood and acrylic and marking both of those, capable of marking stainless steel and capable of marking anodized aluminium. So, a pretty good all-round head. One thing it isn't capable of, but this is the same for all diode lasers, it's not capable of cutting things like clear acrylic. If you're interested in being able to mark all manner of metals, then the 1064nm head is absolutely fantastic for this job. As we've seen, it's capable of marking chrome-plated tool steel, it's capable of marking brass, aluminium, copper, and even plastic as well. If you were running a small jewelry business and all you wanted to do is to be able to, personalize jewelry, for example, this would be absolutely fantastic for that. It can mark at quite high speeds, but if you want a particularly deep etch, then as usual with laser cutters, you've got to sort of play around with the speeds and powers. But yeah, some really, really nice fine engraving out of the 1064nm head, it has to be said. If you're interested in buying the Twotrees TS2 Laser Engraver or any of its accessories, I'll link all those things in down below. Thanks for watching this episode of Leslie's Lab. If you want to see more content like this, don't forget to hit like and subscribe down below, and I'll see you guys next time.